Hi, I'm Alastair Cooke, and this is my innocuous cover slide because I didn't want to break the break cover on a phrase that I was taught really early on as I started building my first application. My first application was a thing called AutoLab, and I was never happy with it. It was never right. But then I got taught this one phrase from software development: effort, ship it. It's never going to be perfect. You got to send it out. You've actually got to ship it before you find what you can do to improve. But you'll also find there's a subtext here of how I learned to stop worrying and love automation. Because when we start out with this idea that the code that we've written, the new feature we've written, the new product we've written looks good, we think, well, it looks good, effort, ship it, send it to production. What happens? Everything is fire. Even the fire is on fire. Because, yeah, something went wrong. There's something wrong with my code. I put a semicolon in the wrong place. Incidentally, a semicolon missing is enough to send a rocket in a pretty destructive course. Happily, I don't know that from personal experience. Although rockets are also interesting for software development because I was talking to somebody who was writing software for missiles. He said, my code needs to only function for 17 seconds because that's the point at which the self-destruct charge goes off. So everything on fire is fine in some circumstances, but most of us aren't writing code for that. Most of us are writing code that's got to do something either for our users or for the general public. And so when everything is fire, we tend to need to fix things. We tend to get told that that's not acceptable and we should have tested this. We should have known it was going to be fire and not shipped it. So we get told, go do some testing. Test your stuff before you deploy it out. Build it in a test environment. And spend more time making sure it works correctly. Oh, by the way, that's an operations problem. That's not a developer problem because deploying into production is an operations problem. So the operations team, or as my father used to be, a QA engineer, does the testing, writes the testing, and then feeds back to the developers and says, hey, this code, yeah, it's fire, but the wrong kind of fire. So we get the cycle of testing. Now, because we handed the testing to somebody who's not the developer, developers are writing new features. This is what developers do. It's what we sent them to do. Make the code work, make the new features for the business work. If we separate out that testing from development, we don't actually end up fixing the problem. What we end up with is more innovation in the code that requires more testing by the operations team, which slows down the rate at which we can deploy, giving more time to the developers to build more features that need more testing. And this is where that waterfall process starts to fall apart. And so one of the things we really need to do is to avoid this manual testing, manual writing of things, because people make mistakes. It's one of the fundamental concepts is that people are going to make mistakes. If you haven't designed to accommodate those mistakes, then you've designed to have those mistakes cause failures. So we like to not rely on human beings being infallible the way computers are. Oh wait, they follow our instructions perfectly most of the time. And this is a central concept within DevOps. The idea of DevOps is to rapidly get new code into production, but do it in a way that is safe. And safe for this context here at Security Field Day also means secure code. When I talk about safety, it's got to be safe to actually run, but also long-term safe for our organization. Central principle of DevOps is deploying new features out rapidly and safely. Incidentally, if you hear hero numbers about how many times we deploy, those aren't nearly as useful as the hero number of the latency between we need a new feature and we need it in production. That, to me, is the best metric for a DevOps environment. And one of the central principles for DevOps is to automate things, automate testing in particular. So we have CI/CD pipelines where new code gets put through functional testing, gets put through security testing. Those elements like scanning for known vulnerabilities in the libraries that you're using, static code analysis as well as dynamic code analysis, checking for buffer overruns and checking for regression back to previous libraries that we knew we had problems with previously, and somebody's accidentally pinned their code to the wrong version. So automation is an absolutely central part of DevOps, and automation of testing is central in there as well. One of the crucial things as we start implementing a DevOps practice is that we're automating the process of testing. We're being absolutely certain that the tests that we run in our test environment replicate what's in our production environment. One of the challenges here is having enough equipment that we can replicate production for testing. Because if we don't replicate production, then our testing doesn't represent what we're going to have in production. So high fidelity testing is important. And then another element is deployment. If you're the development team, you look at the operations team or anybody that's not developers and say, those guys are a bunch of idiots. Every time they do something, they mess it up. And so we want to see automation of deployment. And this is what we see in a mature DevOps environment is it's not just continuous integration where the software is built automatically, but the deployment into production is automatic. Another thing to think about at this point is if we have this automated deployment into production, it's important to think of our production environment as a test environment as well. So we should be doing continuous validation that our production environment is safe. It's not enough to have just done an analysis of our code at the point that we compiled it and built the deployable artifact. New vulnerabilities turn up over time. We discover that there was a compromise of a library that we were using last week. Well, if we're not scanning our production environment, or at least validating that what's currently in production is secure, we're going to get exposed again. So very much as you start doing this automated deployment, your production environment is the ultimate test environment. And the old saying that everybody has a test environment, some people are lucky enough to have a separate environment from production. Well, now you start treating everything with that same degree of instrumentation. One of the things I come back to as I start thinking about this is that there's still a lot of places where you don't have automated deployment processes and automated test processes, where you have that overworked human who is doing all this work, who is trying to follow the three-ring binder full of instructions of how we deploy and we build this environment. How the heck is that safe? If you can't automatically deploy your application safely, can you safely deploy it at all? So as you are approaching a software development project, as you're supporting a software development project, if you're integrating security into a software development project, we want to be doing this: write it, test it, ship it. The write it's probably the only thing that's not going to be automatic, but give the AI some time.